Breaking news. At 0642 UTC this morning, automated alert systems across the planet activated within the same 60-second window. Data streams from space-based observatories and ground stations began flashing red in control rooms from Pasadena to Darmstadt to Santiago. Engineers in California froze mid-sentence. Analysts in Germany stared at silent monitors. Astronomers in northern Chile watched the same impossible pattern unfold in real time. Today, the impossible just happened. Moments ago, the interstellar object known as 3I Atlas executed a maneuver no natural body has ever been observed to perform. It did not accelerate. It did not fragment. It did not erupt. It stopped. Not gradually, not over hours. It halted within measurable minutes relative to the sun. This changes everything we thought we knew. If you want real-time updates on the most mysterious cosmic events ever recorded, make sure to like, subscribe, and stay with us, because what you're about to hear is not speculation, it is data, and it is unprecedented. The confirmation arrived almost instantly. NASA's Deep Space Network detected the anomaly first, a sudden collapse in Doppler shift across all tracking frequencies. Seconds later, ESA's European Space Network verified the same result from Madrid and New Norcia. Almost simultaneously, optical observatories in Chile reported a motionless point of light where only moments earlier a fast-moving interstellar traveler had been racing inward. At the Atacama Large Millimeter Array, technicians halted routine observations and pivoted all dishes toward the target. In Maryland, mission analysts at NASA received a priority packet marked with the highest anomaly classification. In Paris and Darmstadt, emergency coordination calls began before sunrise. This was not a single sensor glitch. This was convergence. Within minutes, the James Webb Space Telescope was retasked to infrared bands between 0.6 and 10 microns. Hubble followed, locking onto visible light contours. Radio arrays in South Africa and Western Australia joined the network, searching for correlated electromagnetic signatures. Harvard's Center for Astrophysics paused ongoing simulations. Caltech's Jet Propulsion Laboratory initiated rapid response gravitational modeling. The European Space Network opened continuous telemetry channels. 3 continents, dozens of instruments, one conclusion. 3I Atlas was no longer obeying inertial motion. For context, 3I Atlas was identified as an interstellar object because of its hyperbolic trajectory and extreme velocity, approximately 41 kilometers per second relative to the Sun. It was never gravitationally bound to our solar system. It was passing through, a visitor from another star system, carrying with it material older than Earth itself. Until today. 48 hours before the event, everything appeared stable. Orbital solutions showed a clean hyperbolic path. Distance from the Sun measured 1.3 astronomical units and decreasing. Surface temperature estimates hovered near 210 Kelvin. Spectroscopy revealed carbonaceous compounds, water ice, and trace silicates. No jets, no coma, no rotational instability. 11 hours later, subtle discrepancies emerged. Tracking stations at Goldstone recorded a fractional deviation in velocity, just 0.07 kilometers per second. Insignificant on its own, but when Madrid and Canberra confirmed the same offset, analysts paused. Solar radiation pressure could not explain it. There was no detectable outgassing. 6 hours after that, thermal maps from Atacama showed uneven heating. Instead of the expected gradient, hotter sunward, colder trailing, the surface displayed segmented temperature zones fluctuating by as much as 35 Kelvin in minutes. No known passive process could produce such controlled thermal behavior. 3 hours before the main event, rotational light curves revealed something stranger still. 3I Atlas, which had been tumbling chaotically since discovery, began to stabilize. Its spin rate slowed by nearly 9%, its axis aligned toward a fixed orientation in space. Angular momentum appeared to dissipate without energy loss. Then came the moment that stopped the world. At 0642 UTC, Doppler tracking collapsed, the velocity vector dropped, instruments recalibrated, then recalibrated again. Radar ranging confirmed the result. 3I Atlas had reduced its relative velocity to near zero with respect to the Sun, slowing from over 40 kilometers per second to less than 0.3 kilometers per second in under 4 minutes. The implied deceleration exceeded 3,000 meters per second squared. No natural force in interplanetary space can do this. There was no collision, no solar flare, no gravitational encounter. The object simply arrested its motion. Emergency calls were placed within minutes. Dr. Elena Moravec at ESA initiated a Level 4 anomaly response. Dr. Jonathan Reyes at Caltech ordered immediate N-body simulations, injecting real-time telemetry into gravitational solvers. At MIT, computational physicists began modeling hypothetical plasma interactions and exotic drag fields. Nothing fit. As the world's observatories focused in, new anomalies appeared. Ultraviolet spectroscopy detected transient emission lines at 121.6 nanometers, hydrogen Lyman alpha, pulsing at precise intervals, every 19.7 minutes, every 12.9 minutes, every 7.8 minutes, prime number spacing. Radio telescopes picked up faint broadband emissions centered between 1.4 and 1.6 gigahertz, not narrowband, not encoded speech, but structured oscillations repeating with mathematical precision. This was no longer random.
This was responding. High-resolution imaging revealed subtle shape changes. The object's elongated form began compressing along its major axis. Over 42 minutes, its aspect ratio shifted from nearly 4.6 to 1 to 2.9 to 1. Volume remained constant. Mass estimates, derived from gravitational perturbations on surrounding dust, did not change. No natural process could produce such symmetry on that timescale. Then came the silent division. One region of the surface separated, not explosively, not violently, but cleanly. A secondary fragment detached and drifted exactly 3.2 kilometers away, then stopped as well, maintaining perfect relative position. Two bodies, both stationary, both emitting synchronized pulses. At Stanford, machine learning classifiers trained on millions of cometary and asteroidal behaviors returned a null result. No analog, no precedent. Two hypotheses emerged inside emergency scientific briefings. The first, the mainstream explanation, proposed that 3I Atlas might be composed of an exotic interstellar material capable of rapid phase transitions under solar radiation. Proponents suggested magnetized plasma sheaths, previously unknown crystalline ice structures, or ultraporous aggregates that could interact with the solar wind in unprecedented ways. They pointed to gaps in our understanding of interstellar chemistry. They argued for caution. The second hypothesis was more unsettling. It proposed that the object was not passive, that the deceleration was controlled, that the pulses were intentional, that 3I Atlas was actively managing its momentum through mechanisms beyond known physics, or beyond natural physics altogether. Dr. Marcus Havel of Harvard reportedly stated during a closed session, "If this behavior were observed in an engineered system, we would describe it as active stabilization." Then came the second wave. 17 hours after the halt, one fragment vanished. Not faded, not drifted out of range, it disappeared across optical, infrared, radio, and radar bands simultaneously. No debris, no energy spike, no warning. The remaining structure adjusted within minutes, redistributing mass to preserve balance. Relative spacing stabilized to within centimeters across thousands of kilometers. At the same time, Earth began to feel subtle effects. Magnetometers aboard low Earth orbit satellites recorded a localized disturbance of 0.5 nanotesla, Minor, harmless, but synchronized precisely with the pulse intervals from 3I Atlas. Radio blackouts flickered over parts of the South Atlantic. Navigation satellites reported transient timing errors measured in nanoseconds. Power grids experienced micro-fluctuations too small for consumers to notice, but large enough for engineers to log. Inside mission control rooms, the atmosphere shifted. Encrypted channels multiplied. Data access tightened. Public updates slowed. Analysts noticed that certain datasets were quietly reclassified. World governments were briefed, not on conclusions, but on uncertainty. No one announced panic, but no one dismissed it either. As hours turned into days, emissions from 3I Atlas began to synchronize. Pulses aligned across wavelengths. Thermal output stabilized to within fractions of a Kelvin. The object's surface grew smoother in infrared imaging, its contours sharpening with geometric precision. It was no longer behaving like a debris. It was behaving like a system. I remember staring at the data feed as the realization set in. The numbers were calm. The graphs were smooth. The equations balanced. And yet nothing about them felt reassuring. Because for the first time in recorded history, we were not simply observing an interstellar object. We were witnessing behavior. Scientific teams launched massive simulations. Gravitational models incorporated hypothetical negative mass effects. Spectral analysis searched for signatures of exotic particles. Computational frameworks tested scenarios involving electromagnetic confinement and space-time perturbations. Every model failed. Nothing in standard physics allows a kilometer-scale object to shed 40 kilometers per second of velocity without catastrophic energy release. Nothing. Then, quietly, another anomaly appeared. The remaining body began to align. Not with the Sun, not with Earth, but with the ecliptic plane at an angle that matched no natural resonance. Its orientation corresponded to a vector pointing toward a region of interstellar space approximately 18 light-years away. No known gravitational influence exists in that direction. Yet, the alignment held. This was no longer coincidence. Human reactions unfolded in parallel. In NASA control rooms, engineers spoke in whispers. At ESA headquarters, crisis teams rotated in 12-hour shifts. At observatories across Chile, astronomers refused to leave their consoles. Internal memos leaked describing non-standard object dynamics. Diplomatic channels lit up as governments quietly compared notes. Airlines rerouted polar flights due to intermittent radio disturbances. Bird migration tracking networks reported unexpected deviations across Eastern Europe and Central Asia. Small things, subtle things, but synchronized. In the calm that followed the chaos, reflection began to replace urgency. For centuries, we believed the universe was indifferent, a vast arena governed by blind equations. We believed explosions were accidents, alignments were coincidences, and motion followed immutable laws. But what if some visitors arrive with purpose? What if some objects do not merely pass through, but pause? Maybe we are not witnessing the end of certainty. Maybe we are witnessing an invitation. 3I Atlas remains stationary relative to the Sun as of this recording. Its emissions continue at low levels. Its geometry holds. Instruments remain locked on target, logging every photon, every pulse, every deviation from expectation. The data keeps coming. The models keep failing. And one question refuses to fade. If it can stop, what else can it do? Subscribe to follow the next update, because whatever 3I Atlas is, its story is far from over. And when it moves again,